Hello everyone. Today we will be discussing about the exponential function. In the exponential function, what is the exponential function and the graph of exponential function and some basic properties. So to start with, let's say I have a function f of x which is represented by a to the power x, where a is always greater than 0. This is the condition for an exponential function, right? For example, I can write 2 to the power x, 3 to the power x, 1 by 2 to the power x, 1 by 3 to the power x, and so on. These all are the exponential functions. These all are the exponential functions. We will basically categorize it into two parts. The one is when a is greater than 1 and 1, and the other part where the value of a is between 1 and 0. So in these two parts, we will study the graphs of the exponential function and understand that in which section the graph is increasing and in which section the graph is decreasing. So let's proceed with it. So let's take the case 1. In the case 1, I'm writing a greater than 1. When I say a greater than 1, then the values of a, that will be 2, 3, 4, 5, and so on, right? The values could be even 2 by, not, the values could be even 3 by 2, or it could be uh, 5 by 4, and so on. Right. What I mean to say is we have to take only those values for which a is greater than 1. So firstly, to construct the graph, we have to take one example. So let's say I am taking the example 2 to the power x. Now when 2 to the power of x is equal to f of x, to draw this graph, I must be knowing that at what x the value f of x will be. So to do this, we need to find the points. So we can find the points as, let's say, x here and f of x here. So x is, let's say the value of x is 0, 1, 2, -1, and -2. And f of x, correspondingly the value of f of x, just put these values of x in this function to get the f of x values. So it will be 1. When x is equal to 1, the value is 2. It is 4, 1 by 2, and 1 by 4. Now we need to construct the graph of this function. So to construct the graph, we have the following points, and we can construct the graph very easily. So to construct, let's draw the axis. So these are the axes. Now, if these are the axes, so let's draw the points. This point is 0. This point is 1, 2, -1, -2, and here we have 1 by 4. Here I am having 1 by 2. Here I am having 1. Here I am having 2, and somewhere here 4. Right? Now let's draw the points. So for when x is 0, the f of x, this line is f of x, and this line is x. So when x is 0, f of x is 1, right? This point. When when x is 1, the f of x is 2. So somewhere around this point. When x is 2, the f of x is 4. Somewhere around this point. Similarly, here point for -2 and for -1. When we will join these lines, when we will, sorry, not lines, when we will join these points, we will be getting a curve. When we will join these points, we will be getting a curve. And this curve is proceeding like in this manner. So what can I say is that the graph of fx is equal to a to the power x, where a is greater than 1 is a curve, is a curve, not a linear graph, and is a curve, not a linear graph, and increasing. Now, where the word increasing come or came from, this is important to understand. So, what we can do is we can understand it like assuming the points. Let's say we are having some point here. I'm naming it as f of x1 and some point here f of x2, right? For corresponding f of x2, there is a point somewhere around here which will be, let's say, x2, and for corresponding f of x1 there must be a point which will be x1. It is obvious, it is obvious from the following scenario that x1 is, it is obvious from the following scenario that x1 is greater than x2 and f of x1 is also greater than f of x2. What does that mean? That simply means that as that simply means that as the value as the value of input increased, as the value of input increased, the value of output also increased. As the value of input increased, the value of output also increased. Or what can I say, that for x1 greater than x2, f of x1 is greater than f of x2. That shows that shows that the function is increasing. And we can also observe it directly, as we observe always the graph from left to right. So when we observe the graph from left to right, we can see that the graph is moving upwards, or it is moving from lower values of y to higher values of y. Hence, the graph is increasing, right? So this is how we can conclude with the exponential function, with the exponential function where a is greater than 1. Now we need to take the case 2. For taking case 2, I can say the value of a must lie between 0 and 1. If the value of a lies between 0 and 1, then what will be the scenario? So to calculate or to understand it, let's take some examples. For example, I'm taking 1 by 2 to the power x, or I can take 1 by 3 to the power x, and so on. 1 by 2x to the power x, 1 by 3 to the power x. Any example that you want to take, you can take and draw the graph. So for drawing graphs, we need points. So let's say I'm taking f of x is equal to 1 by 2 to the power x. Now fx is equal to 0, 1, 2, minus 1, minus 2, and f of x will be 1, 1 by 2, 1 by 4, 2, 4, right? So these are the points for of f of x for corresponding values of x. Now let's draw the graph. For drawing graph, we can have two axes. This is f of x and this is x, right? And Now we will plot the points. So 0, 1, 2, -1 and -2. This is somewhere 1 by 2, sorry, 1 by 4. This is 1 by 4. This is 1 by 2. This is 1, 2, and 4 here. Right? Now, for 0, when x is equal to 0, the f of x is equal to 1. When x is equal to 0, f of x is equal to 1. When x is equal to 1, the f of x is equal to half. So somewhere here, right? When x is equal to 2, the value of f of x will be 1 by 4. And similarly, when x is equal to -1, the value is 2. And when x is equal to -2, the value is 4. We will draw the graph, just joining the points. The graph is not that much accurate because I'm drawing freehand. Okay. But what can I say from the graph is what can I say from the graph is now the graph is completely different from what we have expected. And it is also obvious because the conditions are changed. As the conditions are changed, so is the graph will also going to be changed. Now in this graph, what we are observing is the first thing that we observe is the graph is again graph for f of x is equal to a to the power x, where a is greater than 0 and less than 1 is a curve again, and also it is decreasing graph or decreasing function. Now why it is decreasing function? So again, just take some points. We can take some points here. Let's say we are taking this point and this point. This will correspond to this, and this will correspond to this. This is x2, this is x1. So now we can say that x1 is lesser or greater. X1 is greater than x2, but f of x2 is greater than f of x1. Or I can say f of x1 is lesser than f of x2. Now in this, the input is increased. Input is increased, but the output is decreased, or vice versa. What I mean to say is that if we are moving from x2, if we are moving from x2 to x1, if we are moving from x2 to x1, that means our input is increasing because we are talking about the negative side, right? So x2 is smaller and x1 is greater. So we are moving, if we are moving from x2 to x1, that means our input is increasing, but the value of y or the value of fx is decreasing as it is going from f of x2 to f of x1. Hence, it is a decreasing function. And also by looking at the graph moving from left to right, we can say that, or by just observing as we move from left to right, to left side to right side, that from left side the higher values of y are there, but as we are moving to the right side, the values of y are becoming less. Hence it is also a decreasing function. So what could we conclude from this? What conclusion can be made? What conclusion can be made is that f of x for an exponential function. F of x is a to the power x, a to the power x, where a is greater than 0. And in this, we are considering two cases when a is greater than 1 and one time when the value of a lies between 0 and 1. Right? When a is greater than 1, then the graph then the graph is increasing function. It behaves as increasing function. But when when the value of a is between 0 and 1, the graph is decreasing function. It behaves as decreasing function. Right? There is one small point which is left. The small point is that what is uh, the limiting value? The limiting value of a to the power x. Does it does it meet x-axis? So the answer is no. It does not meet the x-axis. A to the power x is fx. So if x tends to minus infinity, then if x tends to minus infinity, then in two cases we have to discuss. Either the a is greater than 1 or a is less than 1 greater than 0. If a is greater than 1, then a to the power minus infinity will be 1 upon a to the power infinity. So this will be f of x. What happened? This will be f of x, right? And if this is f of x, then I can say that f of x is tending to 0, but it is never going to be 0. It is tending to 0, but it is never going to be 0. Hence, it does not meet the x-axis. Similarly, with this case, if a to the power minus x, right? So a is between 0 and 1, that means it is a fractional value. And if it is a fractional value, then any fractional value to the power minus infinity will result in a very smaller value, will result in a very smaller value, a value which is tending to 0, but it never becomes 0. Hence, in that case, we can say that the the graph of a to the power x equals to fx is never meeting is never meeting the x axis. If you find it useful, give a like. My name is Prakhar Jain. Thank you.